Let's start by reviewing the calculations for a regular point sample. This will refresh what may be a dim memory, and I'll be able to emphasize the role of the volume basal area ratio, or V-bar. The V-bar is central to a double sample, so please keep V-bar in mind as we go.
This table shows the layout for one method of point sample calculations. We'll fill in the table as we go through the calculation steps. There are many ways to arrange the calculations, but they are all the same in the end. This method emphasizes the role of the volume basal area ratio and is the most straightforward. The calculations are for point 9 in the example cruise 1. The cruise tally is in Appendix 1. The essential information is that the trees are tallied by dBH and log height with the BAF10. Get the point sample calculation page in Appendix 5 in the workbook and fill in the calculations as we go through the steps. Step 1. Enter the tree tally in the table. There are 4 trees tallied at the point. 2 trees are 14 inches dBH with 3 logs. 1 tree is 14 inches dBH with 3 1/2 logs, and 1 tree is 22 inches dBH with 3 logs. Step 2. Find basal area per tree. Tree basal area is the dBH squared multiplied by 0.005454. This converts dBH in inches to basal area in square feet. You can find the derivation for this formula in any forest measurements book. Basal area for the first 2 trees is 14 squared times 0.005454, which equals 1.069 square feet. The third tree is also 14 inches dBH, so it has the same basal area. The fourth tree has basal area 22 squared times 0.005454, which is 2.640 square feet. The 3 14-inch trees have the same basal area. What separates them in the volume calculation is the height.
Keep in mind that this is the basal area of a single tree. Cut the tree at dBH and measure the area of the stump. A point sample also uses basal area per acre. For this, cut all the trees on an acre and measure the area of the stumps. Per acre basal area comes in later. Step 3. Enter the volume per tree from the volume table. In this case, the volumes are board feet, and the table is the Misavage and Gerard Scribner Form Class 78. The volume table has been abbreviated to show the essential information. The 14-inch 3-log tree contains 146 board feet. The 14-inch 3 1/2 log tree contains 156 board feet, and the 22-inch 3-log tree contains 458 board feet. In this cruise, the volumes are in board feet. In fact, the volumes can be in any units, weight in tons or pounds, cubic meters, cubic feet, cords, whatever. I even saw one point cruise where the units were number of insect egg masses. Regardless of the units, we'll refer to everything as volume and volume basal area ratios. Step 4. Calculate and enter the volume basal area ratio for each tree. For the 14-inch 3-log tree, the V-bar is 146 divided by 1.069 square feet, for 137 board feet per square foot. For the 14-inch 3.5 log tree, the V-bar is 156 divided by 1.069 square feet, which is equal to 146 board feet per square foot. For the 22-inch 3-log tree, the V-bar is 458 board feet divided by 2.640 square feet, which is 174 board feet per square foot. Notice that for each of the tree sizes, the V-bar is less than the board foot volume. The V-bar is the number of board feet on 1 square foot of basal area. Since each tree has more than 1 square foot of basal area, the V-bar is smaller than the volume. If the basal area of a tree is less than 1 square foot, the V-bar is larger than the volume. In a point sample, the V-bar is the equalizing factor. Trees are selected on basal area, and all the tree volumes are adjusted to 1 square foot of basal area. The board foot V-bars have been rounded to the nearest 1 board foot. Other units, such as chords, may need to be rounded differently to account for the differences in relative unit size. In general, it is better to use too many decimals than too few. The volume basal area ratios are the most important part of a point sample. V-bar is the equalizing factor that puts all trees on a common basis. Trees are selected on basal area, and all the tree volumes are adjusted to 1 square foot of basal area with the V-bar. Trees with areas bigger than 1 square foot shrink, and trees with basal areas smaller than 1 square foot expand. This is also where tree height comes into the calculations. The 3 14-inch DBH trees have the same basal area, but one tree is 1/2 log taller. That makes the V-bar higher, even though both trees have been adjusted to 1 square foot of basal area.
Step 5. Enter basal area per acre for each tree. This is easy because there are no calculations. Each tree represents 1 BAF's worth of basal area per acre, regardless of DBH, height, or species. For this sample, the BAF was 10, so each tree represents 10 square feet of basal area per acre. There are 2 14-inch 3-log trees for 20 square feet of basal area, and 1 each of 14-inch 3.5 log trees and 22-inch 3-log trees for 10 square feet of basal area for each one. Step 6. The volume per acre per tree calculation is almost as easy as the basal area per acre per tree. Volume per acre is equal to basal area per acre multiplied by the volume basal area ratio. The 2 14-inch 3-log trees have a V-bar of 137 board feet per square foot and 20 square feet of basal area per acre. The volume per acre for this tree is 2,740 board feet. The 14-inch 3.5 log tree has a V-bar of 146 board feet per square foot and 10 square feet of basal area per acre. The volume per acre for this tree is 1,460 board feet. The 22-inch 3-log tree has a V-bar of 173 board feet per square foot and 10 square feet of basal area per acre. The volume per acre is 1,730 board feet.
The V-bar times basal area per acre is common in all point sample calculations. The volume for each tree has been standardized to 1 square foot of basal area using the volume basal area ratio. The basal area per acre for each tree is 10 because it is the BAF used to collect the sample. So, volume per acre per tree is the V-bar times the basal area per acre.
Calculate the total board feet per acre and total basal area per acre at the point. To do this, simply add the volumes and basal areas per acre for each tree. There is a total of 5,930 board feet and 40 square feet per acre at the point. The basal area per acre at the point is not really necessary in a regular point sample calculation, but it will be used to calculate an overall V-bar for the point.